All right, so moving on to the back side of our ticket to retake. Number 7, we've got another graphing problem. So we want to take a look at our function, f of x equals x squared plus 2x minus 3. So this is not vertex form. We don't have the parentheses like we did on the last problem. Here's our standard form, ax squared plus bx plus c. To find the vertex in standard form, it's not any of those numbers. It's not the a, b, or the c. We have to actually do a little bit of math to find it. Oops, oops. So we're going to, there we go. We're going to find it by using our little negative b over 2a formula. So we have a negative, and then our b value is the coefficient of x, so that's going to be a 2, over 2 times, and the a value is the coefficient of x squared, so 2 times 1. We have negative 2 over 2, which is negative 1. So remember, when we do our negative b over 2a, that's going to give us the x value of your vertex. Now to get the y value, we're just going to plug that into the function. When we plug numbers in, especially in standard form, you got to use parentheses. So I'm going to plug in a negative 1 for the x's, but I'm using parentheses anytime I plug that number in. Otherwise, I'm likely to get back a wrong answer. So now we're just going to calculate that, and we get negative 4. So the rest of our vertex is negative 4. So we can go ahead and plot that point. Let's see, negative 1, negative 4 is right there. That is the vertex of the function. The axis of symmetry is the vertical line that's going to cross right through that. So our axis of symmetry is x equals negative 1. And again, we can just take note that a x value of your vertex is the same as your axis of symmetry. Now, because we use this negative b over 2a to find the x value of your vertex, we also can use this to find the axis of symmetry. All right, the y-intercept. So the y-intercept in standard form, it is one of the numbers of our function, a, b, or c. It's the c value. If we were to mathematically find it, we could plug in a 0 for x here, a 0 for x there. Those two terms would simplify away because they would just end up being 0, and we would be left with that negative 3. So the y-intercept is 0, negative 3. All right, so show work or explain how you would find more points on the parabola. So I just need you guys to tell me what the graphing pattern would be. Remember, it's a 1, 3, 5 multiplied by our a value. Because our a value up here is a 1, it's not going to change the 1, 3, 5 pattern. So we will keep that pattern. So from the vertex, I'm going to go up 1 to the right 1, up 3 to the right 1, and up 5 to the right 1. And then I'm going to get the left side of the parabola, up 1 to the left 1, up 3 to the left 1, and up 5 to the left 1. All right, so let's just do a couple quick checks. Our a value is positive, which means the parabola opens up, which we did do in our graph. Let's see. The a value was 1, so it did not get any wider or narrower than the parent function, which is true for this. The y-intercept is at a negative 3, so are we crossing the y-axis at negative 3? And here's where we're crossing the y-axis, and that is at a negative 3. So that is a good graph. I think we're doing good there. All right, so number 8, you want to surround a 10-inch by 7-inch painting with a frame that is x inches wide. Write a quadratic function a in standard form to represent the combined area a of the picture and the frame. All right, well, that sounds very confusing. Me personally, I'm drawing this out. If I'm not provided with a picture of this, I'm going to draw it out in detail so that I can kind of make sense of what we're looking at here. So first we have a 10 inches by 7 inches painting. So here's my painting. I'll make this 10 and that 7. It's got a frame around it. and the frame is X inches wide. So the frame, I'll make it a little bigger just so I have space. Here's this nice big frame. We don't know how long the frame is, but we do know that it's X inches wide. So it'd be X inches over there, X inches there, and then same thing up here. That's X inches, and that's X inches. So find the combined area of the picture and the frame. So area of the combined picture and frame is a rectangular shape, so it's going to be length times width. So we have to find the new length and the new width of this framed painting, and then we can find the area. We will just multiply them together. So to find the combined length and width, maybe I'll do this one first. So how long is this? Well, right here we knew that that's 7 inches long. Okay. But it got longer than that, right? We added on an X to the top. So I'm going to go ahead and add on the X to the top. And then we also added on an X to the bottom. So I'm going to add in another X. So our new length is 7 plus X, or we have two X's, so 2X plus 7. There is our width. Now the length, same idea. We want to know how long is this whole thing. Well, it started out 10 inches, so we've got our 10 inches, but then we added on X to the right, and then we also added on X to the left, and if we combine those, I don't know what happened over there, we have X plus 10, or 10 plus X, so that is 2X's plus 10, and there's our new length. Oh, there we go. Well, okay. Oh, I erased that somehow. This was 2X plus 7. All right, so length times width, we're just going to multiply those together. 2X plus 7 times 2X plus 10. You can multiply this with a box, or you can distribute. I'm going to distribute quickly. 2X times 2X, we multiply the 2's and get 4. And then when you multiply x's, you get x squared. Then we have 2x times 10 is 20x. Now we have to distribute the 7. 7 times 2x is 14x, and 7 times 10 is 70. So our area is 4x squared. We've got these x's to combine. 20x and 14x gives us 34x, and then plus 70. Let's see, our label, we are in inches squared for area. All right. Oh, that X didn't want to stay. Oh well, get rid of it. What is the average rate of change of this function over the interval from -3 to 4? So what do we do when we see rate of change? We circle it. We write in the word slope. So I want those to be connected in your brains. Average rate of change is slope. And then once we see this as a slope problem, then we understand, okay, we need two ordered pairs, and we'll just do our slope formula. So the ordered pairs come from, or the x values of the ordered pairs come from this interval right here that they give you. There's your x1, there's your x2, because we want to know the average rate of change when the x's are from -3 to +4. So let's see, -3, +4. What we have to do is figure out the y values. So what you can do is on your graphing calculator, if you go to the y equals, you can type in your function and then look at the table of values. All right, so here you can see a graphing calculator. I went to the y equals right here. and I just typed in the function 2x squared plus 3x plus 7. So next, I'm just gonna, I don't need to graph it. I want this table right here that's in blue. So we're gonna hit our second button and then table, and we'll see a table of values for this function. All right, so here's the table of values. We just want to find the two ordered pairs where x is a -3 and x is a +4. So here's x is a -3, the y value is 16. And when x is a 4, the y value is 51. So I'm just gonna move this out of the way, maybe. Let's try that again. Oh, there we go. And I'm just gonna fill that in. We said 16 and 51. Then I'm going to get rid of it. So now we're going to find the slope or the rate of change for those 2 points. So we've got y2 minus y1, so 51 minus 16 over 4 minus a -3. So 51 minus 16, that gets us 35. And then 4 minus a -3 does turn into 4 plus 3. When we subtract negatives, they go positive, and we're going to get 7. And then 35 divided by 7 is 5. So the average rate of change over that interval is 5. All right, so number 10, when will f of x equals 2x exceed g of x equals, or 2 to the x exceed g of x equals 10x? Explain how you know. All right, so this is another one where we're going to use our graphing calculator. We want to type in these two functions into our y equals and then compare the table of values to help us answer this question. Okay, so I'm actually going to change this equation. I want g of x to be a -x plus 5. All right, so when will f of x exceed g of x? Explain how you know. So let me show you guys a couple of visuals on this. All right, so here are 3 screenshots of our graphing calculators. First one, you can see that here's where I typed in our two functions. In y1, I put 2 to the power of x. In y2, I put -x plus 5. I went ahead and graphed it just so I could show you guys the visual of what it's asking. So the question is, when will 2 to the x power, which is our blue function, exceed or be greater than our other function? So here's our 2 to the x power. It's this blue one right here. So this whole time right here, do you see how it's below the red one? That means that these function values are smaller than these function values. And it stays below the red function until after this spot. Once it hits there and it moves beyond, now all of our function values in blue are greater than the function values in red right below them. So we want to figure out, well, where is that happening? Because it does start out less than the other function, and then here's where it's equal to the other function, and then it exceeds the other function. So a table of values is a great way to help us find that. When we look at this table of values, we just want to track the function values. So here's our y1, here's our blue function, here's our red function. So we want to see, when do these numbers get bigger than these numbers? So if I kind of start at, here's 0.5 and 6, so it's not bigger yet. 1 and 5, it's not bigger. 2 is less than 4. 4 is greater than 3. Okay, so when x is a 2, it's already exceeded. When x is a 1, it has not exceeded yet. So what that tells me is that, like, this table right here doesn't give me the exact value where it does start to exceed it, but I can tell that it happens between here. Like when x was a 1, it was less than the other function. When x was a 2, it was greater than the other function. So it happened between a 1 and a 2 for our x values. So one way I could answer that question is, when will f of x exceed g of x? Between x equals 1 and x equals 2. I know it happens somewhere between those two values. That's about as exact as we're going to get with a table of values here. Explain how you know. We looked at the table of values. And I just showed all those table of values too. All right, last two questions. Over what interval is the graph of the given table increasing? So a nice quick way to do a problem like this is, let's do a sketch of the graph. It's y equals 6x squared. So because we don't have any numbers added in, that means that our vertex is at the origin, and our a value is a 6, which makes it positive. So there's just a quick sketch of our parabola. So every parabola has an increasing and a decreasing interval, and it turns at the vertex. The vertex serves as a turning point for our increasing and decreasing. That's what switches from one to the other. So the way that we do that is we read graphs left to right, just like how we read, English. When we come in from the left and we hit our graph, see how we're going down. We hit our vertex and it turns, and now we're going up. So this right here is where our function is decreasing. I'm going to put a D for decreasing. Our function values are getting smaller. Then right here, it switches, and now our function values are getting bigger, and they're increasing. So where does that switch happen? That switch happens when x is a 0. So on the left side of our turning point, this whole side over here, our function is decreasing this whole time. So that side is where all the x's are less than 0. Over here, after we have our turning point and after 0, on this side, we're going to be increasing the whole time. So on this side, all of our x's are greater than 0. So what I just came up with was the decreasing interval and the increasing interval. So what's the question asking for? Over what interval is the graph of the given table increasing? Well, that's this one. It's increasing when x is greater than 0. All right, number 12. Does the data suggest a linear, quadratic, or exponential model? Use regression to find the function that models the data. All right, so first we have to figure out what type of function this is. So we find our first differences, second differences, and ratios if we have to go that far with it. So our first differences is we are going to subtract our y values. We're going to take this y minus this y, this one minus this minus this minus this. And it's always the y value minus the 1 before it. So we're going to do 2 minus 16, which is a negative 14. Then we're going to subtract these. Negative 2 minus 2 is negative 4. Then we're going to subtract these. 4 minus negative 2. Now when we subtract a negative, it turns to a positive 6. 20 minus 4 is 16. And then 46 minus 20 is 26. So those are the first differences. Do you notice how those numbers are all different? That's our check for linear. We just determined that it's not linear. All right, so now we got to check our second differences. Second differences are check to see if it's quadratic. That's where we're going to take all these differences that we just found, and we're going to find the differences of these. So we're going to subtract these. Negative 4 minus negative 14 turns into negative 4 plus 14. We get 10. Now we're going to subtract these. 6 minus negative 4 turns into 6 plus 4, which is 10. Then we've got 16 minus 6, 10, and 26 minus 16, 10. So our second differences are all the same. That's making this a quadratic function. All right, so we answered the question, is it linear, quadratic, or exponential? Now we're going to use regression to find the function that models the data. So this is where we grab our calculators. We're going to type our table of values into our lists using the stat option, and then we're going to have it calculate a quadratic regression for us. All right, so here's our calculator. First thing we're going to do is we're going to hit the stat button, and then we want to stay in this edit menu. We're going to edit and type in our table of values into two lists, list 1 and list 2. So we're going to hit enter on edit. So here we are in our edit. We can see list 1, list 2. I've already gone in and typed in. Here are the x values in list 1, the x values for y2. You want to make sure that the ordered pairs are kind of lined up horizontally with each other. Now after you've put your lists in, we're going to go back to the stat option. So here we are. We hit the stat. It always sends you to the edit list first. You have to arrow to the right for the calc option. We want it to calculate the regression for us. Now, if we look through our options, we can see REG, REG, REG. These all stand for regressions. So think of a regression as it's like a line of best fit, but it could be the parabola of best fit or whatever the function might be. So we have to remember, what did we say this function was? And oh, look, we can see it right there. We said it was quadratic. So we want to have this calculator do a quadratic regression for us. So quadratic regression is option 5. So we're going to arrow down and we're going to hit enter for quadratic regression. All right, we hit quadratic regression. Oh, my cursor is covering it up. So what it will do is it defaults to saying the X list, it'll say L1, Y list, L2. All that means is, did we put our X values into list 1, which is the first column, and our Y values into list 2, which is the second column? And we did. That's where we entered in our data. So you're going to arrow down until you get to calculate, and you're going to hit enter one last time. All right, and here's the final screen where we're going to get our answer. So we can see we have a quadratic regression. They're telling us standard form, y equals ax squared plus bx plus c. And then they're giving us the a, b, and c values to plug in when we write our own function. So a is going to be a 5, b is a -9, and c is a 2. So get that out of the way, and we can go ahead and write our function. Maybe I'll say f of x equals, so ax squared, we said that a is a 5, so it's going to be 5x squared, plus bx, our b is a -9, so minus 9x, and then our c value is a 2, so plus 2, and here is our quadratic regression. That is the best quadratic function that will model the data in that table. And that was our last question. All right. Nice job, everyone.